The James Webb Space Telescope has just unveiled an extraordinary cosmic discovery. A team of astrophysicists has spotted not one, but 6 rogue planets drifting freely through space, completely untethered by any star's gravity. These mysterious wanderers are slightly larger than Jupiter and, incredibly, have no star to call home. Instead, researchers at Johns Hopkins University believe these rogue worlds, located nearly 1,000 light-years away from Earth, were born in the same dramatic process that gives birth to stars. This discovery opens a thrilling new chapter in our understanding of the universe. But what exactly are rogue planets? Let's find out together. Explore the fascinating world of rogue planets. Planets that drift alone in space without a star. Learn how they form, survive, and what they teach us about the universe. Discover why these mysterious wanderers are so important to science and the possibilities they hold for the future of space exploration. Imagine a planet drifting alone in the vastness of space, far away from the warmth and light of any star. These mysterious wanderers, known as rogue planets, travel through the universe on their own, without being tied to any solar system. While most planets, like Earth, orbit around a star, rogue planets are different. They move freely through space, untethered to any sun. In this video, we'll explore what rogue planets are, how they form, and why they are so intriguing to scientists. We'll take you on a journey through space, where we'll discover how these lonely planets survive and what they might mean for the future of our understanding of the universe. Rogue planets are planets that do not orbit a star like the planets in our solar system do. Instead, they drift through space on their own. Imagine a boat floating in the ocean without an anchor. That's how a rogue planet travels through the universe. These planets are often referred to as interstellar planets or free-floating planets. Most planets we know of, including Earth, Mars, and Jupiter, are bound to a star by gravity. This star provides them with light and heat, which are essential for life as we know it. But rogue planets are different. They don't have a star to orbit, which means they exist in the cold darkness of space. The idea of planets wandering through space without a star was initially a theoretical one. Scientists and astronomers have long speculated about the existence of such planets based on mathematical models and simulations. Early theoretical work suggested that planets could be ejected from their solar systems or form independently in interstellar space. Finding rogue planets is a challenge for scientists because these planets don't have a star to light them up. Most planets are discovered by the way they affect the light from their star. But since rogue planets don't have a star, they're almost invisible in the darkness of space. However, scientists have developed clever methods to find them. One method is called gravitational microlensing. This technique works by watching how light from a distant star bends when a rogue planet passes in front of it. This bending of light can reveal the presence of a rogue planet, even though the planet itself is too dark to see directly. Another way to discover these planets is by detecting the faint heat they emit. Even though they are far from any star, rogue planets can still produce a small amount of heat from their internal processes, like radioactive decay, which can be detected by powerful telescopes. The first direct detection of a rogue planet came in 2011. A team of astronomers led by Michel Mayor and his colleagues used data from the gravitational microlensing technique to identify a potential rogue planet. This discovery was made during a survey called the OGLE Optical Gravitational Lensing Experiment, which was designed to search for dark matter and exoplanets by monitoring the brightness of millions of stars. During the survey, the team observed a gravitational microlensing event, where the light from a distant star was temporarily magnified by the presence of a massive object passing in front of it. This massive object was identified as a rogue planet. This discovery confirmed that rogue planets exist and can be detected through the gravitational effects they have on background stars. Following the 2011 discovery, the field of rogue planet research expanded rapidly. More rogue planets were detected using similar microlensing techniques, as well as other methods such as direct imaging and radio observations. Each new discovery provided more information about these mysterious objects, including their distribution, size, and potential for hosting life. One notable discovery occurred in 2018 when astronomers identified a rogue planet with a mass similar to that of Jupiter. This finding provided valuable insights into the variety of rogue planets and their potential characteristics. The continued exploration of rogue planets has led to a better understanding of their formation, dynamics, and distribution throughout the galaxy. The advancement of technology has played a crucial role in the discovery of rogue planets. Modern telescopes, such as the James Webb Space Telescope (JWST), and other space-based observatories have significantly improved our ability to detect faint and distant objects. These instruments allow scientists to observe the faint thermal emissions of rogue planets and conduct more detailed analyses of their properties. How do rogue planets form? Rogue planets can originate in a few different ways, each involving unique processes that set them adrift in space. Let's delve deeper into these formation mechanisms. 1. Ejection from a solar system. The most common theory for the formation of rogue planets is that they start off within a solar system, just like planets that orbit a star. During the early stages of a star system's formation, many planets are formed from the same disk of gas and dust that surrounds their star. These planets can have orbits that are close together, and their interactions can be quite chaotic. Sometimes, a planet might be kicked out of its solar system due to gravitational interactions. For example, if a larger planet or a nearby star exerts strong gravitational forces, it can push a smaller planet out of its orbit. This can happen in crowded star clusters or during close encounters between stars. Once ejected, the planet becomes a rogue planet, drifting freely through space without a star. Think of it like a game of billiards. When two balls collide, one can be sent in a new direction. Similarly, when planets in a solar system interact gravitationally, one can be knocked out of its orbit and sent into interstellar space. 2. Direct formation in space. Another way rogue planets might form is directly in the interstellar medium, the vast empty spaces between stars. In this scenario, the process is a bit different from the typical planet formation we see in star systems. In the cold, dense regions of space, gas and dust can come together to form a planet without the presence of a star. This process involves the same fundamental steps as planet formation around a star, but on a more isolated scale. Gas and dust particles clump together due to gravity, forming larger and larger bodies until a planet is created. Since there is no star to provide the energy and heat, these planets remain dark and cold. Imagine creating a snowball by rolling a small ball of snow in a snowy field. As you roll it, the snowball grows bigger. Similarly, a rogue planet forms by accumulating gas and dust in space, growing larger over time. 3. Planetary embryos and failures. Sometimes, rogue planets can form as planetary embryos that fail to complete their development. In a young star system, not all forming planets will end up as full-fledged planets. Some might be too small or face too many disruptions to coalesce properly. If these embryos are pushed out of their solar systems or fail to join with other forming planets, they can end up as rogue planets. Consider a factory where several items are being assembled. If some items don't pass quality control or are discarded during the process, they might end up as incomplete products. Similarly, planetary embryos that don't fully develop can become rogue planets. For disruption of protoplanetary disks. Protoplanetary disks are the disks of gas and dust that surround young stars and serve as the building blocks for planet formation. Disruptions in these disks can lead to the formation of rogue planets. If a star-forming region becomes unstable, the gravitational interactions within the disk can cause some of the material to clump together and form planets. If these planets are not captured by the star's gravity, they can be ejected into interstellar space. Imagine a whirlpool of water with debris in it. If the whirlpool suddenly changes, some debris might get thrown out into the surrounding water. Similarly, disruptions in a protoplanetary disk can cause newly formed planets to be cast out into space. The formation of rogue planets is a complex and fascinating process that offers insights into the dynamic nature of the universe. Whether they are ejected from their original solar systems, formed directly in the vastness of space, or emerge from disrupted protoplanetary disks. Rogue planets challenge our understanding of planet formation and survival. By studying these wandering worlds, scientists gain valuable information about the history and evolution of planetary systems, both within and beyond our own solar system. One of the biggest questions scientists ask is whether life could exist on a rogue planet. Without the warmth and light of a star, these planets would be extremely cold and dark. However, scientists have found that some rogue planets might have thick atmospheres or even oceans beneath layers of ice, which could provide some warmth. This means that, in theory, life could exist in these hidden environments, though it would be very different from life on Earth. Imagine living on a rogue planet. It would be like being in a place where it's always night, with no sun to provide light or warmth. The planet's surface would likely be frozen, and any life would need to find creative ways to survive in such harsh conditions. The importance of studying rogue planets. Studying rogue planets is important for several reasons. First, they help scientists understand how planets and solar systems form. By learning more about how planets can be ejected from their solar systems, we gain insight into the dynamics of planet formation and the forces at work in the universe. Second, rogue planets could help us learn more about the possibilities of life beyond Earth. If life can survive on a rogue planet, it would suggest that life might be more common in the universe than we currently think. Finally, studying rogue planets can improve our understanding of the galaxy itself. These planets may contain clues about the materials and conditions present in the early universe, offering a glimpse into the history of our galaxy. What does the future hold for rogue planets? As technology advances, scientists hope to learn even more about rogue planets. Future missions could include sending spacecraft to explore these distant worlds up close, or using more advanced telescopes to detect and study them from Earth. There's also the exciting possibility that one day, humanity might be able to visit a rogue planet. While this is still a far-off dream, the idea of exploring such a mysterious and unique type of world is thrilling. In the meantime, astronomers will continue to search the skies for more rogue planets, hoping to unlock their secrets and answer the many questions they pose about the nature of our universe. In conclusion, rogue planets are among the most fascinating objects in the universe. These lonely wanderers drift through space, far from the warmth of any star. Yet they hold the potential to teach us so much about how planets form, survive, and perhaps even support life in the most extreme conditions. As our technology and understanding of the universe continue to grow, so too will our ability to study these mysterious planets. Who knows what incredible discoveries await us in the vast, starless regions of space where rogue planets roam. Whether you're an aspiring scientist or simply curious about the cosmos, the study of rogue planets is a reminder of how much there is still to learn about our universe. So, keep looking up and remember, there's always something new to discover among the stars, and even in the spaces between them. Thanks for watching, and don't forget to like, subscribe the channel, and hit the bell icon to stay updated on our latest videos. See you next time.